Hello, this is John Baugh, and we are covering functions, and we're doing a review of the midterm and also going over Project 1 today. The coverage for this chapter is Chapter 6, which deals with functions. The name of the chapter is Functions and an Introduction to Recursion. However, we will not be covering recursion. We're going to do functions and get quite a bit of depth out of that, and also we are not covering function templates in this chapter, even though they're introduced. There's a whole lot of information in this chapter, and I don't expect you to know all of it, but you should be familiar with what we covered today and what's in the supplemental materials as well. There's a verbose amount of information, 18, 19, 22, 20 some subsections in Chapter 6. So I mean, there's quite a bit of information. So we'll start with some basics, though. As I'm firing up Visual Studio and getting the project set, we'll discuss why we need functions. We've already dealt with functions, but in the form of member functions of a class. What we have as member functions of the class are that they allow you to access, either in a modifying or non-modifying way, the internal data members of your class, or allow you to perform some sort of operation. Okay, so let's call this Chapter 6, Functions. Okay. So we have seen functions before. They're not completely foreign to us, but we haven't really done much. I've only alluded to and done some simple examples, possibly involving what we call global functions. Okay, these are functions. Typically, when someone says function and they're talking about from the perspective of C++, they mean global function. So if I say member function, that is a function that exists inside of a class. If I say global function, then that's a function that exists outside of a class. So in a language like Java, if you're familiar with a language like Java, then you know that all of the member functions, which are called methods in Java, live inside of classes. But in C++, we don't have to have everything live inside of a class if we don't want to. We can have functions, again called global functions, that exist outside the class. For example, I don't have any classes defined. I just have my main function here. This is one perfect example of a globally available function. This is the function, or the entry point, that's executed when you actually launch a program, is this function right here. You'll notice it has very similar syntax to what we had with the class, except you don't have a class name and a scope resolution operator here. It's just the return type and the name of the function, the two parentheses, the curly braces, and then you have a return value inside. But we can define other functions too. So one way to define a function is we can have void functions or value returning functions. These are two different types. We've kind of talked about them before. A value returning function, not surprisingly, returns a value. That means that you have it perform some operations, possibly an input that you give it via parameters, which we've talked about before, or it just provides some sort of data for you or does some sort of operation. Now, if it returns a value, if it actually replaces the function call with a value, then it's a value returning function. If it does not return a value, it's what we call a void function. So let's write a value returning function called square, and it takes one parameter. Now, what I could do is I could write the function definition here, and we know that the definition of a square is basically the number times itself, correct? Okay, so we have num times num. That's all it does. And then down here, I could do something like this. I could say square of 5. And then the next line, I'll say square of 10. Okay. And if we build and run this, we will see that the output is as expected. We get 25 for the first one and 100 for the next. So this is an acceptable way to write an additional function inside of C++. However, it is conventional to not write the full function definition before main. Okay. What we want to do is we want to have main being the first fully defined function in the file because it's the entry point. So here's what we're going to do. I'm going to delete this. I'm going to put a semicolon after this. So what this does is it gives main the heads up that there's going to be another function named square. But then we actually define it below main. Okay, you do the same thing essentially. We don't have to have a named parameter here in the what we call the function prototype. Okay, this is the function prototype, or function declaration. We don't need to have that name here. We can actually just say int if we want to, because we're not actually making use of any variable here. This name really is actually ignored by the compiler in the function prototype. So what we have with the function prototype is it basically just tells the compiler I have an integer returning function named square that takes one integer parameter. That's why this isn't really necessary. But as a matter of my own style, I always put the name of the some parameter name here. Now these do not have to match. Okay, this one and this one don't have to match. I could call this n right here, and then I could change these to n. These have to match inside, but this doesn't have to match that. Okay, so this is what we call the function prototype again. This is the formal parameter. It's an integer right here, and then when we pass actual data to it, we call them arguments, just like with member functions. Same thing. Okay, so no surprise there. But just remember, put the prototype, which is just basically the header of the function, before main, and then do the actual definition of the function after main. Okay, so we can see that this does work still. Right, 25 and 100 we get. That's exactly what we wanted. So that's a value returning function that takes a single integer parameter. Let's have a void function that is just named print something, and let's say since we've dealt with string so far, we're going to include the string library, and we're going to put string name, for example. Okay. So down here, I'm going to actually define this function. I'm going to put cout hello there, comma, and then name, and then an inline. All right. Now this doesn't do anything until I call the function. Now, since I'm not actually making use of a value that is returned by this void function, I don't call it in between the stream insertion operators like I do with square, because square of 5 is actually replaced by what it returns. With a void function, all that does is it performs a task and then exits. It's not returning a value. Whereas with cout, it's expecting there to be a value here, not just a function call. But I can just say print something, and I'm going to pass the name John into that. Okay. So when I run this, it'll say 25 and 100 from these two function calls here, from the square function. And then in the print something, I passed it John, and it's going to be able to say hello there, comma, and then space, then the name that you pass it. Okay. Now, you are not limited to calling functions from main. You can call functions from other functions. For example, if I did down here, if I said cout, did you know that the square of 200 is, and then I do square of 200. And let's say, actually, since I'm asking a question, I'm going to put a question mark there. Okay. All right. Makes sense. So it'll say, hello there, John, and then on the next line it'll say, did you know that the square of 200 is, and then it'll call square of 200, and it'll return 200 times 200. And in this scenario, we are taking advantage of the value returning function square. So it'll say, did you know that the square of 200 is 40,000? Right? Okay, so that's pretty straightforward, I think. And another thing that we have is we can have functions with or without parameters, and you can have different number of parameters. For example, let's say that for print something, we want the user to pass in a number n. Okay, so I have to update this right here. I'm going to pass in 20 up here, and then I also have to change the definition down here to match integer n. And instead of 200 here, what I'm going to do is we're going to make this a little more dynamic. We're going to say the square of, and then there's a space, and then the number that the user enters. We're going to type the word is, and then we're going to do square of whatever that number that's passed in. So you can take a parameter from a function and pass it to another function. That's fine. Let's see what happens. Okay. So did you know that the square of 20 is 400? Right. You could input information from the user. You could ask them their name if you would like to. I could say something like this. I could have string n and integer input. If I said, please enter your name, and then we wait and they get the name, and then please enter an integer. Okay, and then we can call print something on these variables instead of using a string literal and an integer literal. So I'm going to pass n as the name and input for the data, the integer data. I build it. And notice I did delete the two square calls originally. Let's say Bob is the name and 50 is the integer entered. So right here, this is really interesting what's happening. Is we're getting input from the user that is being stored in string variable n, and the integer variable input that is being passed on to print something. Print something's directly using the name variable, okay, as it prints out hello there Bob, and then for the did you know that the square of, it uses the n variable, the integer, directly in the code here, but then it makes a call on the n that is passed in, which is 50. It calls square of integer n and returns 50 times 50, so we get 2500. Right? So this is an example of a function with multiple parameters. Notice that it is simply separated by comma. You can have a function that doesn't either a value returning function or a void function that has no parameters as well. You can think of parameters as sending data into the function, but we've covered that pretty briefly and or actually pretty thoroughly when we talked about member functions, but this is kind of a review. The syntax is pretty much identical, except we are not calling this function, for example, or this function relative to a class name. I'm not saying my object or my dog or my cat or what have you dot print something. I'm not doing that because this is not a member function. If it were a member function, we'd have to access it via the object of the class. Okay, so that's your basic how-tos as far as it's concerned with global functions. The next thing I want to cover are the math library functions. There are many math library functions, but we'll just look at a couple here. One that you can use to access the math library functions, what I'm going to do is I'm going to clean up this right here, and we're going to pretend we started over here. We'll delete the custom functions we've made. The different libraries that are available to us offer us many different functions that we can use. So these are defined functions that were defined by some really nice programmers, so we don't have to go through the trouble of defining them ourselves. Even the square function can be taken care of with a function provided by the math library. So, for example, in order to use the math library, we have to do an inclusion of the math library. So it's include, and then in brackets we put C math. Okay, so C math. Now, let's say, for example, that I want to print out the ceiling of a number. So CICEIL, and I type 9.5. Or 9 well, let's do 9.3. So that's called ceiling. What ceiling does is it takes whatever floating point that you put in there, and it rounds the number to the smallest integer, not less than that number. So this should be rounded to 10. Let's see if this works. And as we expect, it prints out a 10. Okay. Now, the opposite of the ceiling is the floor. Right? So that will actually, no matter what the decimal point here is, it will remove it, essentially, and it will go down to the integer that's right below. So 9. So that's the ceiling and floor. All right. So you also have others, like a very handy one is the POW function. And for example, let's type POW for POW for power, and you have some number raised to some other numbers. For example, if I want to know what 2 to the power 10 is, I type POW 2, this is the base, and that's the exponent, 2 to the power 10. Some programming languages actually have an operator, such as the caret symbol, which is like, it's on, if you hit Shift 6, that's the caret symbol. So some languages actually allow you to do that, but C++ does not have a power operator, so you have to use this method here. So let's run this, and it tells us 2 to the power 10 is 1024. Okay, so 2 to the power 9. Okay. It's 512. Okay, so these are very commonly used binary numbers since it's 2 to the power. Let's do 5 to the power 9. Okay. All right, so it's a pretty big number here. Let's do 5 to the power 3, just to make it sit down here. If it gets to a certain size number, by default it starts writing them in scientific notation, just like a calculator. Okay, so you've got 125 here. That's pretty much what we expect. And you can pass variables in here too. So for example, let's say I wanted to print out all of the powers of 2 from 0 to 9. Okay, I can say POW 2 comma I, right? And I'll say, just so we know what's what here, I'm going to type as a string literal. I'm going to say 2 to the power, and then I. I'm going to put an equal sign. Okay. So remember, this is just for formatting purposes to make it look a little prettier. This isn't actually being used in the calculation. This is the calculation being performed here. Okay, so build it, run it, and it gives us a little powers table for 2. Okay, that's pretty handy, because what does a for loop do? It goes through each number one at a time, starting at 0. It calculates 2 to the power 0, since I equals 0 the first time through the loop. And then it goes to 1, so 2 to the power 1 is 2, 2 to the power 2 is 4, 8, 16, 32, 64, 128, 256, 512. Okay, so that's pretty handy. So that's the POW function. You also have sine, cosine, and tangent, square root, absolute value, logarithms. There's a whole lot of stuff in the math library, so those are just some of the common ones. Alright, so that's the math library. Now, another thing I want to show you is the random function. The random function can be fairly useful, especially in instances like games. The random function generates an unsigned integer. Now, this is important. It generates an unsigned integer, which means it only generates positive numbers. Now, if you want to generate a negative number, then you basically just have to multiply something that the random number generator generates times -1. You'll have your negative numbers at that point. But it does generate an unsigned integer between 0 and a number called rand_max. This is a symbolic constant defined in the CSTD_LIB, C Standard Library file. So if I want to use rand, I have to include that CSTD_LIB. It should be CSTD_LIB. Okay, so most of us don't want to generate a number between 0 and that extremely large number, so let's see if we can get it to rand_max. So let's see if we can print out rand_max and see how big this number is here. Okay, so it's 32,767. So that's a pretty big number. We don't generally want to generate a number that large. So what we're going to do is we're going to make use of one of the operators we've learned about before, and that's the modulus operator. So we know what modulus does is the modulus operator takes a division, and instead of returning the quotient, returns the remainder. So if I want a number between 0 and 5, always, then I can do this. I can say, I'm going to do it in a loop just to show you that it's going to generate these numbers. Okay, we're going to say rand, then modulus 6. Okay, so think about what this does. This generates some big number, okay, and no matter what number it generates, if we do modulus 6, we will never get the number 6. Okay, because let's say rand generates a 6. 6 modulus 6 is 0, because if you divide 6 by 6, there's no remainder. It's 0. Anything divisible by 6, so 6, 12, 18, 24, if rand generates any of those, it's going to generate a 0. So a lot of people actually refer to modular arithmetic as clock arithmetic, because just like a clock, when you get back up to the 12, it starts over again. Okay, so we would say that's modular arithmetic, where you have a number modulo 12. Okay, so it keeps repeating. What we have here, if this number is, say, 4, 4 modulus 6 is 4, because 4 divided by 6 has 0 quotient and 4 remainder. If it's 8 modulus 6, 8 modulus 6, you have 1 6 can fit inside of 8, and then what's left over? There's 2. Okay, so this is going to generate 2. So rand modulus 6 is going to generate any number from 0 to 5. So let's build this and prove our point here, or at least show that we're reasonably satisfied here. 5544540042. Okay, so that's pretty straightforward. Now let's say let's say that we want to generate a number between 1 and 6. Okay. In order to do that, we have to do what's called shifting. Okay. So what we're doing here to ensure that we're going from 0 to 5, we're doing what's called scaling. We're taking that rand max, essentially, and we're making sure that it never goes above 5 here. That's called scaling. Okay. To make it go from 1 to 6 instead of 0 to 5, we shift it. So basically, this part's going to generate a number from 0 to 5, and then we're going to add 1 to it. Okay, so then we ensure that we never generate a 0, or well, we never print out a 0 here, and we never get a number from 0 to, or we do get a number from 1 to 6, so we get 6, 6, 5, 5, 6, 5, 1, 1, 5, 3. Okay, so that's pretty much what we expect there. Okay. So the next thing that I want to do is go over enums, which are enumerated data types. This is a special type of named constant, essentially. So what we have here, let's say that we have a game that we're playing, and I can do it outside of main or inside of main, it doesn't really matter here. I'm going to do enum game state, and then let's say the game state is let's say splash, like the splash screen of a game, the thing that pops up. So we'll say high score and playing. Okay. So what this is going to do is allow us to actually declare variables of this type, game state. Okay. So let's say later on we have game state, my state equals splash. Okay. So later on, we might check to see if my state is equal to splash. I'm going to say you're at, or welcome to the splash screen. Welcome to the splash screen. Enter your name to continue. Okay, let's say we want a string here, name. And the user enters a name, and let's say we want to change the state to playing, which we can do. That's fine. And then later, we say if my state equal to playing, best game. Okay. All right. So this is pretty interesting. We do this, and I say, it says please enter your name to continue, John, and then it says you're playing the best game ever. If they, let's say that we put another condition here, let's see if this even works. Name not equal to the empty string. Let's say they just hit enter, then it's not going to accept it. So put John, so you're playing the best game ever. Okay, let's say they put a space. I think we had a little bit of an issue there. Okay. Say they put a space. As long as the space, the name they enter is not a space. Let's say they put a space and then hit enter. It's apparently ignoring white space. That's right. All right. Let's say the name is, let's say we want the name John to be a special name. That means something else. So Okay. By the way, we could use cn.getLine to get the string, and it would get it even if it was a blank. So let's take John here, and it just says press any key to continue because it skips this because it never changes the state to playing. However, let's say I put Bob. Since that's not equal to John, it changes the state, and then later on when it says if my state equals playing, you're playing the best game ever. Now, you can imagine, perhaps in a graphical environment or even a text-based adventure game environment, which you might think that sounds funny or is laughable, but text-based adventure games are actually still pretty popular, even on devices like Android and Windows and iOS. I wouldn't say they're as popular as like Angry Birds or not as popular as World of Warcraft or Rift or any of those games, StarCraft, on Windows. But a text-based adventure game is nothing to laugh at. They're actually pretty popular, and you better bet they're using some way to maintain game state, and probably an enum in many of them. So that's an enum. It's an enumerated type. Now, behind the scenes in C++, not all languages, but in C++, each of these is basically a named integer constant. So it starts at 0, then it's 1, then it's 2, and it keeps on going from there. Okay, so these are integers in C++. In a lot of languages, they are not an integer. They're not actually an integer. They're like a full-fledged data type. The next thing I want to go over are scope rules, and this does not mean the rules before going out for a nice dinner, making sure that you gargle scope so your breath doesn't stink. Scope rules refer to where an identifier can be used. Okay, that's called the scope. So, for example, if you declare a local variable in a block, it can only be referenced in that block and in blocks nested within that block. The block scope means if I declare a variable inside of, for example, okay, this would be block scope. If I say for integer I equals 0, less than 10, I plus plus, right here, if I say integer d equals I times 2, notice if I try to compile this, it's already warning me, but if I try to compile this, it will fail. Okay, it'll say undeclared identifier D. That's outside this loop here. That's because this has block scope within these curly braces for this for loop right here. Okay, so that's an example of block scope. Now, function scope. The local scope to a function we'll call it function local scope because the book actually refers to labels which have to do with start and case labels in the switch statement. So that's on page 228 if you're interested, but really people don't usually make reference to that type of scope. But you will have a type of scope that we call local scope to a function, even though it's technically a type of block scope. Let's say this. Let's say I have void do something. All right, and I'm going to call do something down here. Oops. Okay, and I declare variable d equals 10, cout, hi there. Okay, and then I can even hi there. Your let's say d is old. Okay, so this will work here if I call do something. This will print out the 10. Okay, but if I try to say cout D here, it'll say again that D is undefined because this is in the scope of this function. So it is technically a block scope, but we generally refer to this as function local scope. Okay. Now, all right. So the next thing that I want to go over is a type of, it's related to scope. It's called storage class specifiers. There are 5 storage class specifiers that are in your, they're listed in your supplemental material and also I believe in the book. But there's 2 that we're primarily concerned with. By default, we have what's called automatic scope, or automatic storage class. So when we declare a variable in a function, this this basically stores the data for this, or it stores the data, the value 10, in this variable D, but as soon as this function is done being called, as soon as we exit from this curly brace here, after it's called, that memory that was reserved for D here is returned back to the operating system. Okay, so that's because this is what we call an automatic variable. Now, we can use the keyword auto, but it's basically the exact same thing. So automatic data is or automatic variables, automatic storage class is the default. Okay, so that basically means that we can declare it in here, but as soon as this function is gone, or dies, this function is done being called, it will basically disappear. That variable is no longer able to be used. Now let's do this. Let's do something a little tricky here. Kind of interesting. We're going to use a different type of storage class specifier called static. Static and counter equals 0, and I'm going to put counter plus plus here. That increments the counter by 1. And I'm going to say counter is, looking at the counter, and up here I'm going to call do something, and we'll call do something again, and then one more time. Okay, so let's build this, and we'll see how static is different from automatic. Well, this is interesting, isn't it? Didn't I say that a variable died when it got to the end of a function? Well, what happens with static variables are that you declare it once and it maintains the value initially, but on subsequent calls of this function it ignores this call right here because it doesn't reset it to 0. But you have to do it in line. You can't say counter equals 0 on the next line, because that'll reset it, obviously, because that's an assignment operation. But this declaration right here allows us to count or persist a number between different calls of the function. So it is good for the lifetime of the program, but this static variable is only available inside of this function. So that's kind of a distinction between the storage class specifier versus scope. So it does have function local scope. That means I can't refer to counter out here in main. I can't do anything about it in main. I can't say cout counter. So that means it only has function local scope, function scope, function or block scope within the function. Okay, that's the scope. Now the storage class is different. Normally a storage class of a variable would be automatic, which means, again, once the function's done here, it dies. Okay, so if I do this, if I take static off, let's see what happens. It's going to have automatic scope by default. It's going to say 111. That's because the value of counter did not persist between different calls of the function. The memory is reserved for counter, set to 0, then it's incremented to 1 and printed out as 1. Then when we exit this function, after this first call, for example, the variable's returned back to memory. Then the second time we call it, we reserve memory again. It may not even be in the same location. The operating system decides that. We set that to 0, counter plus plus, and then again it's 1 again. But if we change that to static, again, this gives us static storage class. All right. It will persist after calls of the function. So this variable does not die after the end of this function. That's why we get 1, 2, 3 and not 1, 1, 1. Okay, it keeps incrementing it. All right, so that's static. The next thing I want to go over is a topic called pass by value versus pass by reference. So we call it the parameter passing. These are different parameter passing schemes. And these are the two parameter passing schemes in C++. Let's do two different versions here. We're going to say square val, and I'm going to put int a, and then we're going to do square ref int, and then the ampersand symbol a. Okay, we will see what this, why this is different. Okay, so let's say void square val. Now you might ask yourself, if we're going to perform a square, why are we making a void function? Well, we could do a value returning, but another way to, we're going to demonstrate in a second, another way to get data out of a function is to pass by reference. We can pass it as a parameter and say, well, I want to actually change that value and give me back some data. So what we're going to do is we're going to say a equals a times a. All right. And then I'm going to write essentially the same function down here, ref integer ampersand a. All right, that's the reference operator. Okay. So I'm going to say a equals a times a. All right, and now let's see what happens. So we're going to say cout, or no, we're going to say integer mynum1 equals 5, and int mynum2 equals 10. No, let's make them both 5. We could reuse one variable, but this is just to make things crystal clear what's going on here. So what I'm going to do here is I'm going to square val mynum1, and I'm going to square ref mynum2. Okay. Then I'm going to say square val of 5. And I'm going to put mynum1, cout square val of, square ref of 5, mynum2. Okay, so let's see what the difference is. Now the code looks the same inside of here. Besides the fact that these have different names, the only difference here is the ampersand right here in the header and then the function prototype. So let's run this and see what happens. So square val says that it's 5 and square ref says it's 25. Now why is that the case? Here's what happens when you, we have two different scenarios. The pass by value, which is what we have with square val, that's what we've used before, and this new concept, square pass by reference. So that's what square ref does. So even though the code is the same here, they don't do exactly the same thing. Here's what happens. When I say square val, okay, which takes an argument by value, what happens is that I'm passing a 5 to it, and in square val down here where we define it, this a is actually replaced, is actually a local variable. This a is a local variable. It obtains the value 5, and then what I'm saying is I'm saying a, which is my local variable, equals 5 times 5, that's 25. But this has to do with the scope issues. This is essentially a local variable. It's in local scope here. So as soon as we're done with the function and it ends, the value is not changed. Okay, so mynum is still 5. It was never modified. But there are some instances, many instances, in which we want to actually modify the value that we're passing in. So to do that, we pass by reference. This time, we have mynum equal to 5. When we pass it to here, it does not make a copy of the number 5 into a local variable a. What it does is this a here, which could be called anything, really, becomes an alias, or like an alternate name, for mynum2. Basically, you're passing it the memory address, so it basically knows exactly where that A lives in memory. So when we modify it, we say A equals A times A. If I pass a 5 to it, it's going to say whatever that variable is in memory. Now remember, this is an alias for my num2, so it's essentially the same as saying my num2 equals my num2 times my num2. Okay? So that's going to maintain the value 25, and it will actually persist. The change will persist. That's why the second square ref here, printout, will actually say 25, because we've actually modified the value. Anytime we use 25 after this, or use my num2 after this, it'll be 25, unless we change it again later. Okay, so that's pass by value versus pass by reference. You can think of pass by value as pass by copy, because the function basically makes a copy of the variable and stores it in a local variable. It does not modify the original variable that's passed in. Okay, the pass by reference, being different, is like pass by address. You actually are passing an address in, a memory address, so it knows exactly where that variable lives in memory, and it modifies the data to match. Okay, so we've covered quite a bit so far. We've done function prototype, void versus value returning, no parameter versus parameters. We've gone over the math library, the random functions, a random function. By the way, just as a reference, the math library is on page 204 and 205 in chapter 6. It's in that area. Rand is on page 215. Enums, we've covered that. That's on page 220. Scope rules are on 228, and then the storage class specifiers are shortly after that. So pass by value and pass by reference is page 238. It's around about that area. And now I want to go and we want to look at function overloading. This is on page 243. 243 has function overloading. It's section 618. This can be kind of useful in many different scenarios because, for example, let's say that I want to go back to some value returning functions, and I want to use excuse me, I want to use the square again. I want to have one version that takes an integer and another version that takes double values or floating point values, right? So I'm going to put in A here. We know that returns A times A. The double square takes a double A, return A times A. Okay, so we know that if we passed a double to this version normally, if we didn't have this other version, it would truncate the value, and it would not give us the appropriate answer. So let's say we call square of 5 here, and then I'm going to do cout square of 2.5 here. Now, end elf. Let's run this and see what happens. So we get 25 and then we get 6.25. Well, you might ask, well, what's going on here? They both have the same name. This is called function overloading. Okay? Function overloading. Right? So you're basically using functions with the same name, but they have to be different somehow in their parameter lists. Just having a different return type isn't sufficient. We have to be different in the parameter list. So one of them takes an integer, the other takes a double. So which one of these is being called when we call square of 5? They both have the same name. How does the compiler know which one's which? Well, since we pass a 5 into it, it knows that that's an integer. So it looks for the signature with an integer. And in this case, it's this. Okay, it's int square of int a. In the second one, when we have 2.5, it looks for a signature that takes a floating point value or a double. So this is the case here. So even though they do the same thing, in this particular case, we're doing something different based on what value is being passed in. value or values. And this is very, very commonly used, and it's called, again, function overloading. All right, so we're making pretty good time here. The next thing we want to do, I'm going to take a quick break. I would recommend you do the same. Then we'll go over Project 1 and the midterm review. Okay, so we're back in action here. We need to go over the programming project 1 and then go for a midterm review. All right, so the first thing is the programming project. Programming assignment 1. It's worth 100 points, so that should at least get your attention. The assignment is due Friday, June the 21st, 2013 at 11:59 p.m. Okay? The objective is to understand functions, branching code, and underlying mathematics of multiplication in the context of a computer program. So, here are your instructions. Now, you will implement a function called multiply positive. The function should not be inside of a class. So you will deal with functions like we dealt with today, global functions. Okay, so you only need essentially one file. All right, you'll need one file with your main function in it, the function prototype for multiply positive, and the definition below main, just like we did with the other functions today. You will prompt the user for 2 integers. This will be done inside of main. Okay, not inside of multiply positive. This will be done inside of main. You will pass those integers onto the function, which will perform the actual calculations. Then you display the result to the user. Now, the function multiply positive must take 2 parameters, a and b, both integers, that will be used in the product calculation. It must return an integer that will be the product resulting from the multiplication a times b. Okay, you must not use the multiplication operator, as this would make this project entirely trivial. Instead, make use of addition and looping structures such as for or while, etc. So you're not going to just write multiply positive and then inside of the body of this function write return a times b. That would be entirely trivial and totally not worth 100 points. Instead, you have to think about, well, how does the computer, or how did you learn about multiplication? Okay, you basically learned in terms of, well, 2 times 3 would be like, for example, 2 groups of 3, or 3 groups of 2. Okay, or you add 2 to itself 3 times, or 3 to itself 2 times. Okay, so you got 2 plus 2 plus 2, right? If I say 5 times 6, then that's adding 5 to something 6 times, right? So 5 plus 5 plus 5 plus 5 plus 5 plus 5, right? Okay, so you're going to make use of a loop, okay, to simulate this. You must only allow the user to input positive integers. So the driver program, which is inside of the main function, should prevent the user from entering negative integers. So that will be where the branching code or selection statements, like the if statement, if else, takes place. You know, if the integers, or if either the integers they enter are negative, you don't let them continue. You basically break out of the program and tell them what they did wrong. You should display a message such as, you must only enter positive integers, try again. Okay. You will be turning your project into D2L in the appropriate programming project, project number 1. And for this one, you can turn in the source code file, for example, mysource.cpp or main.cpp. You don't have to turn in the entire solution file or project. The file should be present in the top level of your project directory. Okay, so I actually think I had modified the statement here. I think I said here, if you can just download the attached and follow the instructions, and upload the source file. For example, main.cpp. Okay. So you don't have to turn in the entire solution. If you do, I'll still grade it, but go into Dropbox, go under Program Project 1, and then you'll notice when you go into it, you will be able to download this PDF file right here. So it's in PDF format. So if you're on a different platform, you don't have to worry so much. PDF's pretty universal. Okay. Oh, you also make sure you attach the CPP file when you submit your assignment. Do not cut and paste the code or send anything to me by email. I will not grade it if it's not on D2L. If you send something to me by email, all it does is clog up my inbox, and unfortunately they give us a pretty small quota for our inboxes here, so you may cause my email to a couple large size solutions could cause my inbox to fill up pretty darn quickly. So don't do that. If you have a question about code and I say please send me a code sample, then you can attach a source file. Source files probably won't cause a problem, but moving forward, if we get larger solutions, entire projects and solutions, that could cause my inbox to get filled with stuff. Besides that fact, I'm not going to grade it regardless unless it's uploaded to desired aware. So basically you're going to go under the Dropbox, under the appropriate assignment, and then you'll be able to upload it from there. Okay. So yours will look a little bit different because mine's I've got obviously a teacher account. So. All right, so that's the project. If you have any questions, please email me or go onto the discussion board. Actually, what we'll do here is I'm going to create a new forum entirely called Programming Project Help. Programming Project and Homework Help. And okay, I'll do that. And I'm going to add a topic to this. Oops. I'm going to add a new topic, and I'm going to put it under the Programming Project Help, and I'm going to call this topic Program 1, or Programming Project number 1 Help Discussion. Okay, so if you have any questions, you can feel free to post it to the Dropbox. This could be, not the Dropbox, I'm sorry, to the discussion board. So this could be more useful. It might be more useful to other students as well. Okay, so if they have the same question, they can go here and see what you've asked. Now, if you have something extremely specific to your code, you want to email me, or you think it might, cause other people to be able to entirely complete their assignment, I would recommend under the discussion board, do not post your entire code. Don't post the entire implementation and say something like, hey, is this right? Don't do that. Discussions like, can you clarify this? Can you clarify that? Could you, I'm not sure, are we supposed to use pass by reference? Are we supposed to use pass by value? Are we supposed to return or not? Are we supposed to ask the user anything inside of the function or not, etc.? So basically that's what you do there. Okay, so the midterm examination is next up on our list of things to do. And here's how it's going to work. It is a paper midterm. There are only 13 questions on it, but they come in different formats. There are some multiple choice, some short answer. I will go over these one by one, and I'll tell you how much points they're worth. And you can feel free to jot down notes and study that information. You're allowed a cheat sheet. Again, you are allowed a cheat sheet for the midterm. You can have one 8.5 by 11 sheet. Both sides, you can write on both sides. And by 8.5 by 11, I mean 8.5 by 11 inches, not 8.5 by 11 meters or feet. Don't bring in a gigantic poster board. You won't need it because these questions are relatively simple, I think. Again, most of the focus in this course is that it's project-based, not so much testing. So, but I did want to give at least one examination, so I kind of know where everyone's at. Okay. So the first question is worth 5 points. There's 13 questions. First question's worth 5 points. You need to know what you call a variable. Okay, so when I give the variable its name, what is that called? We could call it the variable name, but there's also another word for it. Okay, and I want you to know that word and know what it means, know how to do it, know the syntax. You need to know how to declare, like an integer variable, for example. If I say int a, equals 5, that's a declaration and initialization statement. So if I say int a equals 5, what is a? Okay, I could call it the variable name, I could call it something else. What's that something else? Okay, so that's number 1, 5 points. Number 2, 5 points. You need to know about cout and cin. You need to know the syntax in which they're used, like how to use them. You need to know what library that needs to be included in order for you to use them. Okay. Number 3 is also worth 5 points. You need to know about value returning versus void functions. You need to know what void means, what a value returning function does. If I have a value returning function that returns an integer, what does that mean? Okay, that's number 3. Number 4 is worth 5 points. If I define a class, number 4 is worth 5 points. If I define a class, what do I need to implement to ensure that the internal data members get initial values? So in other words, when someone declares an instance of my class, if I have a class called dog, and dog has weight, name, and age, for example, as data members, if I want to set the name to Fido by default, and the age to 2, and the weight to 60, then how do I do that initially? Like, without the user having to do anything manually, without them except for declaring the variable, the user would just say dog A. Okay, and then automatically, if I say a.getWeight, it should get 60 automatically. I shouldn't have to call, for example, setWeight. Okay, so what can I do to give the internal data members initial values? What do I implement inside the class? So that's worth 5 points. The next one, number 5, is worth 10 points. Okay, 10 points. I give you a segment of code, and it does involve functions. Okay, so you should be able to describe errors in the code. There are 3 errors. So these errors could involve things like variable names being incorrect. They could involve things like libraries missing. They could involve things such as missing semicolons. It could involve something like missing curly braces. It can involve anything like that. These are syntax errors. It could also involve maybe a missing function prototype. It could involve function name being different, where it's called and what the actual name is. It could be any of this stuff, all right, or something slightly different. All right. Okay, you should also, for that one, you should be familiar with the data types we've used. Integer. You should be familiar with string, the string data type. Pay specific attention to string, in fact. Also double, char. You should know all the basic data types. Also bool. String, you should definitely pay specific attention to. How do you use a string? Do you need to include anything extra? Things like that. Okay, so that's number 5. It's worth 10 points. Number 6. We briefly went over this, so you might want to review it in the chapter that involves strings. You need to know a couple of the different member functions that belong to the string class. For example, um, the substring function or the length function, things like that. You need to know those types of functions, just a couple of the basic ones that have to do with strings. Okay. So, number 7 is worth 10 points. I give you a segment of code, and I ask what will happen if a particular variable has a specific value. Okay, you have to tell me. So you should know about the selection statements that we learned about. So if, else, if, and switch, and also the iterative constructs that we learned, iterative control structures such as while, do while, and for. So you should know about the selection control and repetition control structures for number 7. That's also worth 10 points. Number 8, I give you a segment of code, and I ask you to tell me what's printed out by the program. Okay, so I give you code. I will tell you that it does involve 3 things that you need to be familiar with. You need to know about iterative control structures, such as the for, do while, and while. Okay, so iterative or repetition control structures, for, while, do, while. You need to know about selection or branching statements, such as if, else, and switch, again. You also need to be familiar with the comparison operators, such as greater than, less than, equal to. You also have to know division, modulus, and the post-increment and pre-increment and decrement operators. So, for example, I++ or counter++, counter minus minus, or plus plus counter, minus minus counter. Those are the unary increment and unary decrement operators, post and prefix. Okay, so that's number 8. Number 9, I'm pretty much just going to give it to you. You need to know what the break and continue statements do inside of an iterative structure, such as a for or while loop. We did go over that. Okay, that's number 8. I'm sorry, no, that was number 9. Number 8 was the previous one that I told you involved looping and branching and such. Number 9 was the break and continue statements inside of iterative constructs. Number 10 is worth 10 points, and it gives you kind of a word problem of sorts. So I know a lot of you love word problems. So basically it tells you information about variables before a segment of code is executed, and it asks you, it says there's some sort of logic error in the code, and you're supposed to describe. You don't have to write out the code. You just explain how you would correct this. Okay, you can point to the code, you can circle things, but just describe how would you correct the code so that it works the way that we've described it. Number 11, you need to know about the data types we have described in class, and you need to know the exact syntax for them. For example, you'll need to know integer, and if I, for example, ask you what is the data type for integer values, if you say integer, this is a multiple choice one, if you circle integer, then that would be wrong, because that is not the syntax for the data type for integer values. Again, number 11, if I didn't mention it, it's worth 5 points. You need to know integers, floats, doubles, strings, chars, and boolean. Again, integers, floats, doubles, strings, chars, boolean. Okay, know all of them, know the syntax, and know what they are. All right, so what type of data can fill those different variables of those data types. Okay, number 12 is worth 5 points. You should know about the various operators we have learned. You should need to know addition operator, subtraction operator, multiplication operator, division operator, and modulus operator. So you need to know what the actual symbols are for those and what they do. Okay. Number 13 is a fill in the blank. Now there are 2 blanks. Pay very close attention to what I'm saying here. there are 2 blanks. It'll say something, blank, something, something, blank, and then continue the sentence. And it's multiple choice, but each multiple choice answer has 2 words to go in the corresponding blanks. Okay? So only pick one answer. These are not multiple guess. Like, you don't select multiple items. These are all multiple choice. The ones that are have multiple options are all multiple choice. So you will only select one of those. So that's number 13. That's worth 10 points. Okay, so if you need me to repeat that, I'm not going to do it. You just have to, go back in the YouTube video. So, excuse me. If you do have any questions, feel free to email me or post to the general discussions and the discussion board. That's pretty much all I have for you. Again, if you have any questions, please contact me. Have a great day, and we'll see you soon. Bye.